get going. First thing is I want to have a leading one on the very top, and I happen to have a 1 here, so I thought I might as well just move this whole row to the very top. So not touching row 3 and just switching row 1 and 2. Row 2 becomes row 1. It's always a good idea to write on the side what you're doing so that if ever you make a mistake you can check it. So I've just switched my 2 first rows. Do keep in mind, obviously you could do it differently. You know, you could have decided instead to kind of divide this first row by 2. That'd be allowed. There's no just one way of doing things. You might, well, if you don't make mistakes, you'll get the right answer anyway. So I've got a 1 here. That's good news. Now under that one, let me get my nice pen. Under that one, I want only zeros. It's a good thing I already have 1 here, but I want 1 here too. So if I do -2 times my first row and then add this here, this will cancel off my 2, and then obviously this will change all of that. So this is my next step, and let me write this right now. So -2 times R1 plus R2, that's gonna be my new R2. So not touching the first row, not touching the last row because we already have the 0 where we want it to be. So only changing the second row. So -2 times 1 plus 2 is obviously 0. That was the whole idea. I have -3 plus, well, -2 times -1. So these two minuses will cancel. 2 -3 plus 2 is -1. 4, now I have to add -2 times -4, that's +8. 4 plus 8 is 12. And then 14 -6. 3 times -2 is -6. 14 -6 is 8. Right, we're getting there. I now have a -1 here. No, let me see. We wanted a 0, done deal. We have this first column is all good. So now I want a 1 here. The leading number should be a 1. Easy enough, because I just have to do this row times -1, right? -1 times -1 is going to be 1. So I just have to change the signs, basically. Okay, so let me do this properly. And make lots of space, because that's going to take a bit longer. Right. So, still not touching the first row, not doing anything yet to the third row, although you might be able to guess where we're going. And we said that minus row 2 is our new row 2. So 0, 1, -12, and -8. Okay. Next step. Where are we going? This is all good. We've got our leading 1. Should be a 0 underneath. Now this is why it's good to be very systematic, because now what we'll do obviously is -2 times this row plus the next one. So 2 minus 2 will give us a 0, but we won't lose this 0 that we've built, because -2 times 0 plus 0, that's still going to be 0. So we get a new 0 here and different numbers here. So what we'll be doing is -2 times row 2 plus row 3. That's our new row 3. So not changing the first row, keeping the second row the same as well, just changing the last one, but we did say this number won't change. Obviously if we do -2 times this plus 2, we get the 0 we wanted. minus 2 times minus 12, that's plus 24, and we add this to the third row. 24 plus 8, 32. And finally, minus 2 times minus 8, that's plus 16. 0 plus 16 is 16. Good. Okay. Again, that was a good step. This column is fine, this column is fine. We only need to have a 1 here as a leading number. All we need to do is divide by 32. Obviously we do this throughout. That's all we need for this step. Obviously when you get very used to doing this, you can go a bit faster. But for now, let's just do it properly. Right. So we said all we're doing is dividing by 32. So that's a half here. And what we did was row 3, well, times 1 over 32. And that's our new row 3. Good. Okay, and actually we've reached an interesting step here because this is the row echelon form, if not the reduced row echelon form. This is the row echelon form. Leading 1, zeros under, leading 1, zeros under, and leading 1. That's all good. If we were to stop here, that is Gaussian elimination. We've achieved Gaussian elimination, and we could actually stop there if that's all we wanted, because actually if you remember that this matrix is just a rewriting of a linear system that we had, means that we've already found that z equals a half, and we could use this knowledge to solve the other two equations, and that'd be especially easy since, well, in this equation now we only have y's and z's, and we know what z is, and so on. So it's in a quite useful form. We won't stop here, however, because we can go further. So we've done Gaussian elimination, and that's actually the forward face of Gauss-Jordan. So I'll move quickly on because this is getting a bit long. So now what we're wanting to do is to have zeros. So where I have a leading one, where I have a leading one, I want it to be the only non-zero number in the whole column. So I need to get a 0 here, 0 here, and 0 here. And now what we had been doing was to use this one to get zeros under, and now we're going to be going upwards. Doesn't matter if it doesn't make sense right away, you can listen to this again when you're more used to it, or when you have done a few, it'll feel quite natural what I just said. So we want to get rid of this 12 using this 1 that's just below it. That's very handy. And again, since we have zeros here and we obviously don't want to change what we've built, that's great because the zeros I can do, I don't know, it's going to be what, 12 times this plus that. 12 times 0 is 0, so that's not going to affect all of this. Okay, so we're not yet doing anything with the first row. The last row is perfect, not touching it. As I said, this is not going to change, and what we're doing is 12 times R3 plus R2. That's our new R2. Okay. Yeah, went a bit quick there. Sorry. 12 times R3, that's 0. 12 times a half is 6. Minus 8 plus 6 is minus 2. Right, so we got a 0 here. We need another one here. So what should we do? 4 times the last row plus the first one. 4R3 plus R1 will be our new R1. So that should bring us a 0 here. Won't affect this, won't affect that. but we'll obviously change the 3. So last row is the same. We're nearly there, by the way, as you probably can see. 4 times R3 plus R1, 4 times 0 stays the same. 4 times 1 plus minus 4, look at that, that's 0. 4 times a half, that's 2, plus 3, that's 5. Okay, this is very close. All we want is to get rid of this minus 1. We can use this one that's right here to get rid of it. And then we'll have, because as you can see, we've got z equals something. We've already got y equals something. All we want is x equals something. So that's all we've got left to do. Good news. Okay, so what we're gonna do, we want to get rid of this. We just need to do R2 plus R1. Yay. R2 plus R1 is going to be our new R1. Do not touch this last row, that's perfect. Do not touch this second row, that's perfect. Only add the second row to the first one. This plus that does not change. Look at that, it's a 0. We still got zeros. 5 minus 2 is 3. Now this is indeed the reduced echelon form, and not only that, it gives us the solution. If you remember that this was a linear system and all we've done is to build an equivalent augmented matrix, so the system, linear system it represents, has the same solution. Otherwise it would not be an equivalent matrix. This is why we only use the allowed row operations, which means that we've got an answer. So the solution is x equals 3, y equals minus 2, and z equals a half, which you could also write this way. Let me check if that's the right answer from what I've done earlier. Hey, look at that, it is. Good job.